All right, we're going to finally finish 3.1 today. I have just a little bit left to go. We were looking at other bases when we ended class last time, and I believe that we're on example 10. Does that sound right? Okay, great. Okay, so we had encountered these other bases last time. We'd written down some numerals and kind of thought through, when we run out of numerals in a specific base, we talked about the fact that whatever the base's name is, say base 7 means I don't have any 7s. It sort of ends our numerals one digit before that kind of stuff. And what we're going to do is we're going to actually take some specific numbers in some specific bases, and we're going to find the number that precedes and succeeds the number that we are working with. So this is really like what we were doing with the Babylonians and the Mayans and whatever too, when we said what comes before and what comes after. And the base that we are working on will actually have a lot to do with what that answer is. So typically speaking, even as it was inside of the Mayans and so forth and all of them, one of the answers is really easy and one of them is usually really difficult. It's usually easy to either take one away or to add one to it, and the other one's like, now wait a minute, how does that rounding thing work in this system again? And you have to think a little harder. So the number 1, 4, base 5, what comes before 1, 4? 1, 3, that's the easy one. It goes 1, 3, base 5, and then it goes 1, 4, base 5, and then what comes after 1, 4? 2, 0. Yeah, it's a 2, so we don't have a 1, 5, right? So we have to increase what's in the 5's digits place, the second digit over, from a 1 to a 2, and we zero out the last digit. It's right, it's like asking what comes after the number 19. Well, it's 20, right? The 19, the 1 turns into a 2, and the 9 turns into a 0. We want to make sure that when we're writing these down that you write the subscript with it. If there is no subscript written, it is understood to be base 10. As you're working with them, if you want to be very clear to make sure for yourself that you don't forget to always write it, you can even write the 10, like the word 10 as the subscript when that happens too. But this one would be the number before, and this one would be the number after. How about the number T00? We're in base 12. Which one's the easy one, the one before or the one after? After. Yeah, so T00 in base 12. What comes after T00? Nope. T01. Okay, so T01. We just increase that last digit by 1. We're always wanting to either increase or decrease that last digit. Well, it's easy to increase from 0 up to 1. That's why that one's the easier of the two to do. Okay. Is that all right? Are you okay, Marissa? Yes. Okay. The number before is harder because I'm trying to take the number at the end, the 0, and I'm trying to take something away from it, and there's nothing to take it from, right? So I'm going to change this number to our number system, and I want you to think through what actually happens when we have one of these situations. So let's say we had the number 900. So if we're trying to get the number before that, what is the number before 900? Yeah, it's 899, right? So it would be 899 for us. Take a look at how the digits are working. Well, the numbers at the end, the zeros, become 9s, right? The largest digit possible in that base. That's what 9 is. And the number at the beginning simply goes down by 1, right? So if we think through that with our number T00, the T at the beginning needs to go down by 1. What is T? 10. T for 10. That's the way our book does it. T for 10. So what comes before 10? 9. So there will be a 9 before it. And then again, in our system, what we see happen here is we have the largest numbers available in that number system. What is the largest number available in base 12? 11, which is the letter E. That's what our book uses. So the number that comes before T00 is 9EE. And we write the word 12 right here. okay? So when you're stuck and you're like, wait a minute, what am I supposed to be doing? Try and think about what happens when we have something similar in base 10 and how it affects our individual digits. And it will affect the digits the exact same way. What we're going to do next is exactly mirroring what we did next inside of Mayans and Babylonians and stuff too. All right, we looked at the numbers before, the number after, and then we looked at converting. Well, how do I turn something from Mayan into Hindu Arabic, our system? Or how do I turn something from our system back into Roman or something like that, right? That's what we did then, and that's what we're going to do next here as well. So the first one that we're going to do is converting from some other base blank, into base 10. So we're going to do something to turn base 7 or base 6 or base 16 or whatever into base 10. And this is going to look and feel very much like my example last time where I described the crayons on the floor. Do y'all remember that? We came in and we dumped out all the crayons. It's the same idea. So we're going to end up with sort of a pot of crayons on the floor after we do that. And what we did over there is we put the numerals into expanded form. Let me see if I can find that particular one. I think it was this one actually. So this is expanded form where I write the base itself and all the powers of the base. And then I actually do the multiplication and addition to simplify it out. And then our last step is that step 2 where it says to multiply the expanded form. So step 1 is simply writing it out. Step 2 is multiplying. So we're going to do a couple of examples, and I chose specifically for us to do one where the number is a small base, base 2, and then a number is a large base, base 12, to think about how those are affected. So I need to make sure that I'm understanding that the base that I'm in are the powers I'm creating. So there will always be a ones place, and there's going to be whatever number that we have of them, and it's powers of 2, right? So if I have powers of 2, I've got 1, and then I have 2, and then I have 2 squared, and then I have 2 cubed, and oh, that was a 3. 2 cubed, and I have 2 to the 4th. These are powers of 2, right? Okay. So what I tend to do is I tend to write out my 4. Actually, let me do it this way so I can see it a little bit better. It's a 4-digit number, right? Because I've got 1, 0, 0, 1. This is the ones place. This is the twos place. This one's 2 squared, and this one's 2 cubed. If you can write it underneath the 1, 0, 0, 1 space-wise that it's already there, you can do it there. That's fine. There's one of these, 0 of the ones in the middle, and 1 of the one at the end. So I have a 1 in the 2 cubes place. I have a 0 in the 2 squareds place, and so on. And what I'm doing is I'm multiplying that number 1 by 2 cubed. And while I know 0 gives me 0, I'm going to write it out thoroughly so that I don't forget when I look back later that that's what I did. I'm going to have 0 times the 2 squareds place, 0 times the 2 to the first or 2's place, and 1 times the 1's place. Okay, so this is sort of step 1 right here. Anything you do before that's just getting your mind sort of thinking about the clarity of it. If you need it there, great. If you don't, that's fine. But this is the expanded form. And then we need to do the multiplication. What is 2 cubed? 8, thank you. And I'm multiplying it by 1s. This one's 8. The 2 in the middle are multiplied by 0, so there's 0. And the last one is 1 times 1, which is? So this is the very large and exciting number 9. Yes, it is. And you can leave it written as 9, but if you want to just sort of get in the habit, you're also welcome to write that we're in base 10 now next to it. All right, we turned it into a base 10 number. If you don't want to write it, that's fine too. The number is 9. Okay. Powers of 2. Now I'm going to do powers of 12. Okay, so 1 and 12 squared and 12 cubed. So I did it again. 12 cubed and so on, right? So this one's just a 3-digit number. So I have the 1's place starting on the far right. Then I have the 12's place, and I only will go up to 12 squared here. Now, the numbers in these two places are zeros. The number in the 12's place is actually a t. What is t? 10. It's 10. So you can write the t if you wish like that. You can write the 10. Down here, we need 10 of them. We have 10 12 squareds. plus 0 12s plus 0 1s. That's expanded form. And then we're going to multiply. What is 12 squared? 144. And that 144 is now multiplied by a 10. So what's 144 times 10? 1,440. Oops. And you're welcome to use your calculator as you're doing these, because some of them are going to get more, involved as well. So here's what I need you to remember. It's really, really important to put on a note card some point along the way, is that when we're going from base something else into base 10, we are multiplying. It's always a multiplication process. And the reason it matters is because when we go from base 10 back into some other base, again, it doesn't matter if it's bigger or smaller, it's just the fact that we're taking a base 10 number and we're putting it into something else, we're going to be using division. And the division will look just like it did back in those other systems with the, I called it a division scaffolding. All right, so we're looking for division scaffoldings, and we're doing it based on the powers of the place value system we're trying to put it into. So our first example is that we're going to be doing something with base 4. So since base 4 is our number, we need powers of 4. So I've got, and while it was perfectly fine when we were doing it the expanded form before to simply write them as 4 squared and 4 cubed and whatever, we're going to be dividing by these numbers, so we need to know what they are. Right, so I have the 1s place, and then I have the 4s place, and then I have 4 squared, which is 16. Right, this is 4 squared. And then I have to have 4 cubed. What's 4 cubed? It is 64. And then I need 4 to the 4th. And we got to keep writing them out until we get something pretty close to 11,000, because that's my number I'm working with at the beginning. So after 64, what do we have? Yeah, if I have a calculator, you're going to need it for the next two problems anyway. 256 is right. I won't keep writing out the powers above it, but the next one's going to be 4 to the 5th. What's 4 to the 5th? 1,024. And then 4 to the 6th? 4,096. We're getting closer. And if you do it one more time, what do you find? And that's too big, right? It's bigger than my 11,000, so I don't need that last one. But I do need all the ones I already listed before. These are all the numbers that are going to go into my division scaffolding with the biggest one first. So we're going to do the 4096 first with my 11,028. How many times will 4,096 go into 11,028? What's it say? How many whole number times? Twice. And what is 2 times 4,096? 8192, and then we subtract. Okay, so what's 11,028 minus 8,192? I have 36 written down. Okay, 36 maybe? All right. What will I divide by next? Yeah, the 1,024. So how many times in 1,024 go into 2,836? Should be twice. 2 times 1024, you might be able to do that in your head. That's 2,048. So what is 2,836 minus 2,048? 788. So going down our list, we have now taken care of the 4096, the 1024, so I'll divide now by 256. We have to divide by all of them, right? So how many times will 256 go into 788?
3.
All right, and what is 3 times 256? 768. You can probably subtract that one pretty quick. What do you got? 20. And so while it doesn't sort of feel like I really need to, I do need to divide by 64. It's a very unexciting 0. It goes in 0 times, but that 0 is a placeholder that needs to be there. So make sure you're dividing by everything, even if it goes in 0 times. Once I've divided by the 64, I will divide by the 16. So how many times will 16 go into 20? Once. And if I subtract 16, I get 4. So I've done the 16, now I've got 4. And 4 will go into 4 once. And when I subtract, I have a 0, but my last step is to always divide by 1, and 1 will go into 0 times, right? That 0 is still a placeholder that I need. So this would end up with giving me the remainder of 0 at the end, but the last step is always to divide by the 1. And then your answer is right here. It's 2, 2, 3, 0, 1, 1, 0, base 4. So here's something that you can do as sort of a visual check step really quick. It doesn't verify that your answer's correct, but it can definitely show you if you've made a mistake that it might be incorrect. Notice we started out with a base 10 number. How many digits were in my base 10 number that I started with? There were 5 digits, right? It was an 11,000 number. It was 5 digits. I'm changing it to a smaller base. It's base 4. And how many digits are in my base 4 number? 7. Okay? So generally speaking, especially if I've changed drastically, and base 10 to base 4 is a pretty drastic change. If you went from base 10 to base 9, it doesn't always quite look so drastic. But the larger the base, the fewer the digits. The smaller the base, the more the digits. And we saw it happen here, though I didn't make mention of it as well, right? My base 2 number was the number 9. But there was 4 digits in base 2, wasn't there? Right? My base 12 number had 3 digits in base 12, but it had 4 digits in base 10. And they're only off by two base numbers, right? Base 10 to base 12. All right, I have one example left. Whoops, it's this one right here. My number 99,999, and we're going to put it in base 9 where there are no 9s. They don't all turn into something else the same way, but there are no 9s, and so we're going to take a look at what happens in base 9. So in base 9, I have the 1's place and I have the 9's place, and then I should have 9 squared. What's 9 squared? 81. And then I need to multiply, or then I need to do 9 cubed. So what is 9 cubed? It is 729. 9 to the 4th.
6,561.
Very good. 9 to the 5th.
59,049.
Okay. I know I'm not all the way up to 99,000, but you can clearly see that 59,000 is only going to go into 99,000 one time, so I don't really need to find what the next power of 9 is. This will be enough. So we're going to do division scaffolding with our 99,999. And we're going to be dividing the first time by 59,049, and in fact goes in once. So what is 99,999 minus 59,049? Fabulous. Okay, so then what will I divide by? Right, 6,561. So this one's going to go in several times. How many times will 6,561 go into 40,950? 6 times. And 6 times 6561 is 39,366. Is that what you guys got? Good. What do you get when you subtract on that one? Mm-hmm. 1584. And sort of moving down the line, the next number we'll divide by is 729. So So how many times does 729 go into 1584? Twice. And 729 times 2 is 1458. So if we subtract that one, what do we get? 126. So after 729, lower is 81. So that goes in once. 126 minus 81 is, what's my next step to divide by? 9. And how many times does 9 go into 45? 5. And I get the remainder of 0, which is fine, but I can't stop, right? I still have to keep dividing by whatever powers remain. There's only one that remains, it's the 1. 1 goes into 0 0 times. And my answer is right here. 162,150, base 9. And again, notice, how many digits does that base 9 number have? 6. And how many digits did our base 10 number have? 5. So it's a good visual check at the end, just to make sure that you didn't inadvertently use multiplication when you should have used division, or vice versa. Okay, any questions on that? All right, we'll have lots of practice over the weekend.